Welcome to part 2 of this video series on Earth Leakage Test. And make sure you watch the first part where we talked about the theory of the Earth Leakage Test. In this video, we are in our lab. We have a Earth Leakage Test set up, ready to be performed on our Class 1 type medical device. What I have here is we have 3 different Earth Leakage tests programmed into our electrical safety test analyzer, with the first one being under normal conditions, the second one with an open ground, and the third one with an open ground and an open neutral fault condition. So let's take a look at the test parameters in detail before we make the connections and execute the test. So now we're going to go over the test parameters that we need to program before we can actually perform the earth leakage test. So starting with the first test parameter, we have what's called leakage height. This is the maximum allowable leakage current per the test standard. And since we're testing according to the IEC 60601-1, the high limit for the leakage current is 10 milliamps for single fault conditions and 5 milliamps for normal conditions. So we're going to leave that at 10,000 microamps, which is the same as 10 milliamps. Leakage low, we're not too concerned about it at this point. We can set that up later once we know how much leakage current we're going to be seeing on our product. Then we have voltage high and voltage low. So we will be powering up our device using a programmable AC source that's built into this safety analyzer, and it's set to output 132 volts, which is 110% of the rated line voltage of this device. So we have our voltage high at 135 and voltage low at 130 to make sure that the voltage does not change too much. Then we have our dwell time. This is the total test time set as 1 second, which is pretty standard in the industry. We also have a delay time parameter, which we can always program to give our test some extra time or readings to settle down before any pass-fail judgment can be made. That's followed by the offset parameter. If you run into issues with extra leakage current or system leakage, you can always use this parameter to offset any stray leakage that you're going to see. And then on the right side of the screen are the 3 fault conditions: neutral, reverse, and ground. And in the first test step, we're going to leave everything as normal. So neutral is closed, reverse polarity is off, ground is closed. And I just want to show you how this ground switch functions. As you can see, when I have the ground closed, I'm basically providing the current a path bypassing the measuring device circuit back to the neutral side. And in the next step, when I open the ground, you'll see that all the current will flow through the measuring device circuit and we will see a reading. And then we have our measuring device circuit, which is the IEC 60601 per the test standard that we're testing, the medical device standard. And then that's followed by the probe configuration, because we want to make sure that our MD is placed in the right position. So we want to make sure it's placed between the ground and the low side of the power supply. And lastly, I want to show you the AC source setup, which is set to output 132 volts at 60 hertz and in a grounded neutral configuration. Okay, so now we're ready to make the necessary test connections for performing an earth leakage test on our device under test, which in this case is a small medical device, a class 1 medical device. When I have the line cord of this device plugged into the back side of the device, and the other end of the line cord will be plugged into the adapter box of our electrical safety analyzer. And with these connections, we are now ready to perform the test. So let's take a look at the test results from our 3 earth leakage test steps that we just executed. This is the first test step where 132 volts were applied. And as you can see, for the fault conditions, everything was normal and the recorded leakage current was negligible or very close to 0, 0.1 microamps. In the next step, we opened the ground. We simulated an open ground condition. As you can see, the leakage current measurement went up by quite a bit, all the way up to 32.4 micrams. And in the last test step, we have our neutral open as well as ground open, and look at the leakage current reading up to 56.4 microamps. So that's it for our earth leakage test video. In part 1, we talked about the test theory and how the test is performed. And in the second part, we talked about how the test is run. And we actually showed you an earth leakage test being performed on a Class 1 medical device. So hopefully this was helpful. And thanks for joining us for this video, and make sure to stay tuned to our upcoming videos.